Okay, Bismillahirrahmanirrahim. Assalamualaikum. So today I'm going to show you in this video is about independent sample t-test. So the purpose of independent sample t-test is to find the difference of mean dependent variable between two groups, group number one or group number two, right? So basically, in independent sample t-test, we need to have some assumption, right? And the assumption are the dependent variable should be in numerical in nature, right? And independent variable should be categorical with two levels, right? And the sample taken from for this study is independent sample, should not related or should not measure twice. And the fourth assumption is equality of variance or homogeneity of variance, right? And number five is both group number one and group number two should be normally distributed, right? This is for independent sample t-test, right? And the data format in for independent sample t-test is should be should be uh, should be in a long format. Dependent variable and independent variable should be in long format, right? For example, let's say I'll try to open SPSS file hpt.sav. So this is example of data that can be used to run independent sample t-test. It's a long format data. So we have gender and BMI. So now we have a BMI in numerical type or data, right? So we want to know, is there any difference of mean BMI between male and female? So we have gender, male and one for male, two for female. And gender is a categorical variable with nominal scale, right? And the dependent variable should be in continuous data or numerical data, right? So in order to proceed with this independent sample t-test, I'm going to use hpt.sav dataset, right? This is a SPSS file format. So to import SPSS file format to R environment, so I need to use Heaven library. So if you don't have Heaven library installed in your R package, so you need to type install .packages and Heaven, right? So hit enter and it will install for you Heaven package. Once installed, what you need to do is to load the library Heaven, right? So I'm loading Heaven library. So Heaven is for importing SPSS format file to our environment, right? So I'm going to store hpt.sav, this data, right, to R format by using data1 name, right? This is going to be my object in R. So I'm using function read underscore sav, right, function, and then I'm going to choose my data. This is only for SPSS type file, right? Click open. So I'm going already store the data into my R environment. So data 1, we have 126 observation and 6 variable. So if I want to know the names of variable in data 1, so I have gender. The first variable is gender. Second variable ethnicity. Third HPT, BMI, race, and BMI category. So in order to use independent sample t-test, what I want to know is, from independent sample t-test, I want to know, is there any difference on mean BMI, right, between male and female, right? So now I'm trying to view the data, right? So this is the data exactly same as SPSS file. right? So I'm going to check whether the type of variable gender is in factor level. If it's not in factor, we need to change to factor. So I create data1 gender as factor data1 gender. So now if I checking the data is in factor or not, so it's going to return true for me, right? Checking BMI variable is there in is BMI variable is numerical, so is return true. So means that now after making some changes, right, I need to make sure the gender should be in factor level and BMI should be in numerical variable. I need to know BMI is our dependent variable and gender is our independent variable. Gender is independent variable with two levels, right? So if you check levels, data1 gender, it will not return male and female. It return 1 and 2. This is because once we transfer, we import the data from SPSS, it not read the label of SPSS label. What we need to do is now is to change the label, the factor label 1, 2 to male and female. 1 is for male, 2 is for female. I'm using factor, and then I input my data variable name, level, existing level 1 and 2. So level is 1 for male, 2 for female. And I hit enter. Now if I check levels data1 gender, it will return male and female. So next, if I want to know the frequency distribution of the gender, I just type table and the variable name, right? Sorry. So it will return 75 of the observation are male and 51 of the observation are female. So again, the purpose of independent sample t-test is to find the difference of mean BMI between male and female. The research question is there any significant difference on mean BMI between male and female? Right. So now, remember, we have 5 assumptions to make, right? First assumption is the dependent variable is numerical, right? So we already made 5 first assumption numerical is numerical data1 BMI, it return true, and the first assumption is met. And the second assumption is independent variable is a categorical variable. So we need to check again factor data1 gender. So it return true, and another assumption for the second assumption is a categorical variable with 2 levels. So we need to check level data1 gender, it return 2 levels, male and female. And we assume that data the observation are independent, right? Because this is a male and female. There are no measuring they are not measuring twice or a related sample. And next we need to check equality of variance or homogeneity of variance. But this one we can do it later. But the most important part is we want to check whether the both group should be normally distributed, right? So now I'm going to check whether the normality assumption via box plot, using box plot. So I'm using plot. This is x variable, this is y variable, right? So in box plot, the x variable should be categorical, the y variable should be numerical, and this is the title of the box plot. This is a x axis label and y axis label. So if you hit enter this one, right? So you can see that for male, they have normally distributed data for BMI, but for female, there is a slightly skewed to the right distribution, right? So since not both group are not normally distributed, but only one group are normally distributed, another one is not normally distributed, we can relax the assumption. We just based on um, the single one, but however we can check using based on central limit theorem. It says that when the data or the sample observation is more than 30, then the distribution is approximately to normal distribution, right? However, if you don't like box plot, you can use histogram by group, right? In histogram by group, we need to load library ggplot2, right? ggplot2. If you don't have ggplot2, you need to install first. If you don't know how to plot data using ggplot, you can refer to my previous video on introduction to ggplot and introduction to graphing, right? So I'm going to run histogram for both group. So it returned that the first distribution is normal distributed but slightly skewed to the right, and the second distribution, female, is basically normal distribution, but it has a outlier. That's why it shows a skew to the right distribution. So if you want to create a histogram with a normal distribution curve, right? You can try this method, right? So first we need to load dplyr package, right? If you don't have dplyr package, you need to install first, and then I sort the data for male and sort the data for female. dm is for male, df is for female, right? So if you run head dm, so it will return all male respondent. Head df, it will return all female respondent. Now, what I'm trying to do is I'm trying to construct a histogram with a normal curve. So you can get this code at my website, right? So if you can see, so the first function is ggplot, and I put my dataset name and I put my variable name, and then I call geom histogram. I cut the variable into 3. Bandwidth is equal to 3, right? Sample what we call is class size equal to 3, and AES Y equal to density, fill by count, and this is a color that I choose, and stat function, theme and label for x-axis, right? So if you want to do this, you need to have grid extra if you want to display both graph together, right? Let me hit this one and call male and female, and I'm going to get this one, right? So this is my histogram. So if you can see, the first data is normally distributed, the second data is skewed to the right distribution, but however we can say that this is a normal distribution because only few have outlier, right? So then we confirm that this data is normal distributed by looking at the graph, and we can proceed with based on central limit theorem also says that if the data is more than 30, then approximately to normal distribution, and we can say that our data is met for the fourth assumption, right, which is normal distribution for each group. Next, we want to check equality of variance assumption. So to check equality of variance, but we're going to use library car, right? In library car, is allow us to use Levin's test, right? So to use Levin's test function from this package, library car. If you don't have, you need to install first, right? So then I'm going to use Levin's test function to test the equality of variance for BMI and gender. So the BMI, the first variable that you need to input is dependent variable, followed by tilde, and followed by categorical variable, and put center by mean, right? It will return that the p-value, this is the degree of freedom for Levin's test, right? 1 and 124. This is the f value, right? And this is the p-value for Levin's test. If you can remember, the hypothesis for Levin's test is H null equal to the H null is the variance are equal for both group, right? And for null alternate hypothesis is the variance are not equal for both group. So since our p-value is 0.4, which is more than 0.05, we actually reject alternative hypothesis and accept null hypothesis and conclude that the variance are equal for both group, right? So we will proceed with the independent sample t-test with equality variance assumed, right? So to use independent sample t-test is quite simple, right? We can use by using t.test function, right? So if you want to know more t.test function, you just put question mark t.test and hit enter. It will return how to use the variable, the function. The first thing that you need to put is the function itself, t.test, and x, comma, y. X is numerical vector of the value. Y is optional non-empty numerical data value, right? So the easiest way to use is by using t.test, our numerical variable, which is our dependent variable, followed by tilde, right? And followed by categorical variable with two level. And we need to put comma variance dot equal to true. This is if the equality variance assumed. If the equality variance not assumed, you need to change to false because the formula are different, right? So you need to I store this value of t-test into tt, right? So it will return the same things. So based on the independent sample t-test, the t value is 1.9079 with degree of freedom 124, and the p value is 0.05872. So you need to remember the null hypothesis, right? Hypothesis statement, right? The first hypothesis H null is equal to the mean. There are no significant difference on mean BMI. Oops. Mean BMI between male and female, right? The alternative hypothesis H1 is there is a significant difference on mean BMI between male and female, right? So since our p-value is more than 0.05, which is our alpha, so we're going to reject alternative hypothesis. We're going to accept null hypothesis and conclude that there are no significant difference on mean BMI between male and female. So in this result, it also provide you the 95% confidence interval for the test, to test of the different means 95% confidence interval of the mean difference, and the mean group for male and mean group for female. Mean BMI for male is 26.29. Mean BMI for female is 24.43, right? So another useful techniques is to tidy up the value, the result from t-test. This one you look messy. Sometimes we cannot see the result, see the number, right? You can use library Broom, right? So Broom is to tidy up the result into a nice row, right? We can use tidy function, right? So if you want to view Z, so we will put into one row, estimate number 1, estimate number 2, right? Statistic, p-value, parameter, which is this is the degree of freedom, confidence interval, lower limit, upper limit. The method is independent sample t-test, and test is two-sided test, right? So next, to extract mean and standard deviation, we can use mean BMI. So this one, DM is actually, I already filter the data for male, right? I'm using the plier method, right? Basically, you don't need to do this because you already have the mean for male. But if you want to know the standard deviation, the other statistical measures, then you need to do this, right? So we sort the data for male and we call BMI, and we call mean for BMI is actually the same. And if you want to call SD, just type SD, right? This is a standard deviation, right? And same goes to female and female group, mean and standard deviation. So now how to present the data, right? So basically we do presentation like this, right? We put variable BMI, male, female, mean different. Where to get mean different? It will state somewhere here. If you don't have mean different, you can put like this, copy minus female group, mean for female group, then we'll get 1.86. 1.86, but this one is somewhere wrong, right? Right. So this is not an actual result from our data, but this is how we present the result of the one sample, independent sample t-test. And this is the example of result presentation from a journal of plastic and reconstructive and aesthetic surgery, right? They use independent sample t-test. This is the categorical variable, which is your independent variable, and this is your dependent variable, right? I think that's all for now for independent sample t-test, and hopefully you get something from there, and see you. Bye.